Good afternoon, class. We are looking at pre-calculus practice test number 5, module 5, covering chapters 10 and 11. Here's chapter 10, analytic geometry, the second part, reminding everybody of the pledge. I want to make sure everybody realizes that when we take the exam, we take the exam on our own, okay? And it is as though we are taking it on campus, and we can't have unauthorized assistance. That's the bottom line, and I want everybody to be very careful with that. That's the bottom line. And now we want to look at the parabola. So we've looked at other analytic, graphs, analytic geometry. The graphs are circles, ellipses, hyperbolas, and now the parabola. Parabola has a specific definition. A parabola is a set of points in a plane that are the same distance from a fixed point, called the focus, and from a fixed line called the directrix. As a result, a parabola is the set of points P for which. So here's a parabola. If you pick any point and connect it to the focus, and then drop a perpendicular to what is called the directrix, which is perpendicular to the axis of symmetry, the distance from this point to the focus, D stands for the distance from focus to P, this distance, is the same as the distance from P to the directrix. D represents the line directrix. That's a simple definition of a parabola. So if I have this point, this point, this point, or any other point, if I connect it to focus and I drop a perpendicular, they must be the same. Now, in any ways, this one opens up, this one opens to the right, this opens up neither to the right nor up. So its directrix has a different direction. All of them, they follow this. Now, this distance is the same as this distance, okay? That's the bottom line, okay? So pick up a point, connect it to the focus, drop a perpendicular to the directrix. Either way, this format, that format, or this one. Here's P, connected to focus, drop a perpendicular to the directrix. So that's the definition. Focal distance. What is a focal distance? The focal distance of a parabola refers to the distance from the vertex, the point where the axis of symmetry intersects the graph, this point. This point is called the vertex, to the focus along the axis of symmetry. Okay, so this distance, or this distance, or this distance, or this distance. This distance is the same from the vertex to the directrix. This distance is referred to as either P or A. So if you pick any point, we said the distance from that point to the focus and the directrix must be the same. So if it's the vertex, this distance must be identical to this distance. This either we call it A or P, and I like to go with P because we used A when we discussed parabolas in algebra. We're going to go over that in a moment. So I'd rather go with P. So this distance is P, so is this distance, which makes this total distance 2P or 2A, as some texts they call it. So A or P. And again, notice this distance is P, so P comma 0. If you call it A comma 0. Okay. And if that's the case, this point would be negative A or negative P comma 0. So x equals minus A or x equals minus P if the vertex is located at 0, 0, and it opens sideways. If it's at 0, 0 and opens up or down, then the directrix will have an equation of the form y equals something. In this case, it's x. So this is a vertical line. This is a horizontal line. So we follow the formulas accordingly. All right. So having said that, parabolas have many applications in electricity, mechanics, and optics. And I want to remind you, it opens up or down. The vertex is located at H and K, right? Remember that? In this case, the axis of symmetry has the equation x equals h, okay? The x coordinate of the vertex. And so I want to remind you what we learned in algebra and intermediate algebra. We call equation of algebra opening up or down. Y equals a times x minus h quantity squared plus k. The vertex is located at h and k. The parabola opens up if a is positive, and down if a is negative, axis of symmetry, x equals h. That's why I like to use p for the focal distance rather than a, because we used this, if you recall, previously. And so what are the formulas when they open up or down? Y equals ax squared plus bx plus c. So x has degree 2. And the vertex format a times x minus h quantity squared plus k. So this is something we have seen. And the vertex h has coordinate, x coordinate is minus b over 2a. The y coordinate, just plug in. After you find this, just plug in. That is the fastest way. Now, equation of a parabola opening sideways to the right or left. X equals a times y minus k quantity squared plus h, and the vertex remains at h comma k. The parabola opens to the right if a is positive and left if a is negative. Axis of symmetry, in this case, x equals h. In this case, y equals k. So look at this one. So this one has coordinates h comma k. So it's a horizontal line, y equals k. And of course, in this case, it's opening to the right. A is positive, but opening to the left. Okay, the same type of formula, but A is negative. The same vertex h and k. The same equation for the axis of symmetry. So x equals a y squared plus by plus c, or a times y minus k quantity squared plus c. So this is something we've seen and nothing brand new. The vertex, now in this case, k has the equation minus b over 2a. Over here, opens up and down h. The x coordinate is minus b over 2a. In this case, the y coordinate of the vertex. All right, now let's look at a slightly different methodology of writing. Equation of a parabola, vertex at 0, 0, focus at a0, a is positive. The equation of a parabola with vertex at 0, 0, focus at a0, and directrix x equals minus a, because it opens to the right, x equals minus a, is y squared equals 4ax. But again, I'd rather go with 4px, again, because of what we shown in the previous page. So the vertex is at 0, 0, x is ay squared. A is positive, opens to the right, negative opens to the left, just as before. So we're going to write y squared equals 4px, y squared equals minus 4px, depending whether it opens to the right or to the left. Now, the relationship, of course, between a and p is that a is 1 over 4p, or you can say p is 1 over 4a. It works out the same way. If it opens up and down, if it opens up, and here's the vertex, it's important to understand, locate the vertex At somewhere at top of it is the focus, at the bottom, the line directrix. If it opens down, somewhere inside, which means under the vertex is the focus, and at top is the directrix. Same thing here. When it opens to the right, inside, that means to the right is the focus, outside is the directrix. So inside is always the focus. That's how you figure it out. So the formula is y equals ax squared. A is positive, opens up, negative opens down. So, or we can write it in this format now, the format of this, section or course for that matter, x squared equals 4py or x squared equals minus 4py. What is important is the following. We are going to call the focal distance mainly p. In many texts, as I mentioned, they call it a. I highly recommend you go with p. This way we don't mix them up. So with the focal distance, y squared equals 4px or minus 4px, okay? Remember, when y has the exponent 2, it opens sideways. When x has exponent 2, it opens up and down, okay? Which one? Again, it depends, okay? So the relationship between p and a is that p is 1 over 4a or a is 1 over 4p. So even if you stick with what we did in the previous page, that is absolutely fine. All right. Parabola and lattice rectum. Let's discuss the issue here. So we have some sort of a parabola, in this case open sideways, and as everybody recalls, this is the vertex. This distance is a focal distance, which is equal to that. And so what is the lattice rectum? The lattice rectum is that where you see the focal, if you draw a line parallel to the directrix, so this distance, so you, from the focus, you draw a line segment parallel to the directrix. It cuts the graph, the curve at those 2 points. Those are the end points. This total distance is called the lattice rectum, okay? And it's 4 times p. So the lattice rectum of a conic section is the chord, the line segment through a focus parallel to the conic section directrix, which is equal to 4 times p. The length of the parabola's lattice rectum is equal to 4 times the focal length for p. So obviously you continue on both sides. The endpoints lie on the curve. So those are the endpoints, and we can always find them. And so notice the proof in essence. Recall by definition, the distance d from the focus to any point on the graph is equal to distance from p to the directrix. That means this distance. So if you pick from here the vertex, this distance is the same as this distance. So if this is p, so is this one. So this must be 2p. This must be 2p. So if that is 2p, so is this one 2p and 2p. The total is 4p. So that's the proof, actually, if anyone is interested. But anyways, and we can easily find the inputs. All right. As a warm-up example, recall from algebra, given the function f of x equals x squared minus 6x plus 8, which is in the form of x minus 3 squared minus 1, determine which way the graph opens, find the vertex, axis of symmetry, draw the graph, find the domain and range. So this is what we have already done. I'm going to remind you of a couple of things. From here to here, it's given to us to go from this format to vertex format. You can do completing this square. And again, reminding you y equals ax squared plus bx plus c. Sometimes they call this standard form. Sometimes they call this one a standard form. It's a vertex format, a times x minus h quantity squared plus k. So we can see that, for example, a is 1, it opens up. The vertex is located at 3 minus 1. So a is 1, positive means opens up. The vertex, according to this, is located at 3 comma negative 1. And so we have that. The axis of symmetry has the equation x equals 3, because when it opens up or down, we have an axis of symmetry which has the x equals the coordinate, the x coordinate of the vertex. And so that's the vertex. And now to find the y-intercept, you set x equal to 0, which means it's easier to use this one. You get 8, so 0, comma 8. What about the x-intercept? You set the y or f of x equal to 0. So again, it's easier to set this one equal to 0 and factor it. This factors into x minus 2, x minus 4. Because you want two numbers, the product is positive 8, the sum is negative 6. And that means x is either 2 or 4, and that means 2, comma 0, 4, comma 0. Those are the x-intercepts. Let's put a little table with all the information that we have here. So 0, 8 is the y-intercept. 2, 0 is one of the x-intercepts. 3 minus 1 is the vertex. 4, 0 is another one. And I don't want you to worry about this yet. I'm going to discuss that in a moment with the graph. So we're going to say that's the y-intercept, that's the x-intercept. So is this one, this is the vertex. And we are ready to draw those. So this is the vertex located at 3, negative 1. That's the y-intercept of 0, 8. Those are the x-intercepts of 2040. 2040. Now, according to the axis of symmetry, if we go 3 to the left, we get to the y-intercept. So if we go 3 to the right, we must get another point. And that has coordinates 6, 8. So I just wanted to show you the effect of this axis of symmetry is that if I pick any point here and I find it using the axis of symmetry, I can find a corresponding point. Put them all together, and that's the graph. Again, axis of symmetry, x equals 3, of course. And the domain and range. Domain for a parabola that opens up or down is all real numbers. Negative to positive. There is no restriction. Range depends on the location of a vertex. The vertex located at 3, comma negative 1. So the y coordinate is negative 1 and it opens up. So it's from negative 1 to infinity. Negative 1 is included. If it opened down, would be from minus infinity to negative 1. So it's pretty straightforward as far as how the graphing goes. Not much to it, everybody. All right, we are going to move on. Now, what I want to do, I want to continue on that thoughts and add what we have learned in this case. So first and foremost, we are looking at the same function And we want to find the focus directrix, 2 points that define the lattice rectum, reminding you of the vertex, axis of symmetry, the equation, A vertex opens up, intersect. So these are the information we have found from the previous page, and therefore nothing brand new, everybody. P is 1 over 4A, and remember, A is 1. So 1 over 4 times 1. So the focal distance P is 1/4. It's important to understand that. This is the location of a vertex at 3, -1. The focus is inside, and the directrix is a horizontal line below that. So how do we find that? The distance, the focal distance of 1/4 will help us. So in this case, the focus, so again, the vertex starts from here. So starting with this, everybody. The vertex has the following coordinates. So from the vertex, we know the focus is inside, so we're going to go up by how much? By P. So it's very important to pay attention again. I don't know the exact location, but I do know somewhere here is the focus, and here's the directrix. All we have to do, we figure this out, and this distance is, as I mentioned, P. This distance is P. So we're going to go back to the vertex, and we're going to add P units to its y coordinate. The x coordinate does not change. So we're going to add, so the x coordinate remains, the y coordinate is -1 plus P, which is 1/4. And so the focus is located at 3 -3/4. So right there, let me erase my work. So right there, again, this may not be to scale. Now, the line is a horizontal line, y equals something. So the y coordinate of the vertex is -1. We're going to come down by how much? By P units. So y equals -1 minus P. P is 1/4, so it becomes -5/4. And that's the line y equals -5/4. It's very important to understand and recognize that. And so we could rewrite this by moving the -1 there. Write down x minus 3 squared is y plus 1 if we want to follow the format of this course. Now, if you draw a line here parallel to the directrix, that becomes a lattice rectum, which is 4 times P as far as the length is concerned. And as far as finding it, then we have to go with the following formula. So that's the lattice rectum. So you draw a line segment, a chord parallel to the directrix. Now, every point here, the focus and those 2 points have the same y coordinate as the focus. Remember, the focus has a y coordinate -3/4. So this point and this point also have the same y coordinate. What is the x coordinate? You can put it into this equation, this equation, this equation. So y is -3/4. Find x. How do you find it? As I mentioned, you go, perhaps it's easier to go to this equation. Replace the y with -3/4 and find x. If you go through that, you get 5/2 and 7/2. So the points, the end points have coordinates 5/2 -3/4 and 7/2 -3/4. I go over the second method that I believe it's easier. You don't have to go through finding it here. Rather, again, it has got to do with the location of the focus is here. So we have that coordinate. So we have that. Now we're going to go to the right and left. By how much? Well, I hope you remember this distance was 2p. So we're going to go 2 times p to the right, 2 times t to the left. That means go back here, 2 times the p, 2 times 1/4, which is 1/2, to the right and to the left. So the x coordinate, so the y coordinate remains unchanged. The x coordinate, add and subtract 1/2. So the second method is easier. Given the focus, which has coordinates 3, negative 3/4, y remains unchanged at negative 3/2. So at this point, this point, this point, they have the same y coordinate. Add plus minus 2p, that means plus minus 2 times 1/4 is 1/2 to its x coordinate. So add 1/2 and subtract 1/2 from 3. So 3 minus 1/2 gives you 5/2, plus 1/2 gives you 7/2, the same thing. I think this is a lot faster and easier to find. A quick recap. We are interested in finding these 2 points, the coordinates of these 2 points. These 2 points and the focus have the same y coordinate, everybody. Same y coordinate. You can put it into the equations given, this one, and find the missing x coordinates that are 5/2 and 7/2. Or say, okay, I know the focus has this coordinates, so the y coordinate is not going to change, but the x coordinate to the right, to the left by 2 times p, because each distance is 2p, right? The total distance, remember, is 4p. And that will be a tad easier to find 5/2 and 7/2. All right. Identify the coordinates of the vertex, the focus, the length of the lattice rectum, and the equation of the axis of symmetry, and the directrix. Graph the parabola. Y minus 2 quantity squared is 4/5 times x plus 4. And I hope you recognize that quickly the vertex is at -4, +2. And this opens to the right. Class y has exponent 2. So it opens sideways. That means it opens to the right or left. Okay. And this is positive, opens to the right. We can follow y minus k quantity squared equals 4p times x minus h. Now, because it opens to the right, first the vertex is located at -4, 2, and it opens to the right. I'm going to just draw something which is not right, just to give you an idea. So this is the vertex, and it's going to open to the right. So it looked something like that. This is not to scale. This is not the correct one. Okay, I'm just making a point. So because it opens sideways, okay, then the axis of symmetry has the equation y equals 2, okay. And now if we want to find the focus and the directrix, the focus, this is again not to scale. Somewhere here is the focus, everybody, because it's inside. And the directrix is this line. It's a horizontal line. We don't know the equation. I'm making up something which is completely off on purpose. I want to make a point. So we know the graph opens this way. So the focus is inside to the right of the vertex, and the directrix is to the left of that. And all we have to do, figure out this distance, which is p, this distance from here to here is p, and we know a is 1/4p. So 4p, remember, if you go with that one, 4p is 4/5, so p becomes 1/5 or 0.2. So we have this distance. So if I want to find the focus, I go back to the vertex and I say, okay, I want to go to the right by P units, by 0.2, which means I'm going to keep my y coordinate, the x coordinate -4. I need to add P units, 1/5 or 0.2, and that gives me -38.2. Okay. Okay, maybe I erase my work so it becomes clear. So let me actually, so this one, when you get this point, okay? Again, remember the graph looks like that. And of course, this is much more precise than what mine was. Now, I want to come up with the equation of a directrix. Directrix is a vertical line, x equals something. And so go P units to the left of the vertex. The vertex is located at -4, 2. So the x coordinate is -4. And we're going to subtract P because we're going to go to the left of it. So -4 minus P makes it -4.2. And that is the directrix. And this is the graph. Again, I highly recommend after you figure this out, just draw the graph, look at your focus and directrix, not to scale. You don't have to worry about the scale. You can actually work it out because when you put those, it'll help you see where you're looking for those. All right. The lattice rectum is this distance, which is 4 times P, where 4P is already 4/5. We have that. So this distance is 4 P or 4/5 or 0.8. The lattice rectum of a conic section is the chord through a focus parallel to the conic section directrix, which is equal to 4 times P, 4/5, or 0.8. Again, various formulas are here. Now, we go back to the focus located here at -3.82, and we're going to go up and down by 2p. Remember this distance. This distance is 2p. So is this distance. So from here, go up by 2p. 2p is, remember, p is 0.2, so 2p is 0.4. Go up and down. So lattice rectum endpoints, x equals -3.8. You can say x equals -3.8. Put it, okay, so replace it and find the y. You can do that. But I'm going to stick with the second method. That's easier. So given the focus with coordinates -3.8 and 2, x is -3.8. We're going to go to the right and to the left of that by 2p. That means 2 times 0.2, 0.4. So plus minus 0.4. So when we do that, the y coordinate, which is 2, going up by 0.4 gives us 2.4, going down 2 minus 0.4 is 1.6. So you go up and down by 2p, 2 times p units, up and down. So that gives us those 2 points. All right, use the graph of the parabola to determine its equation in standard form. But as far as the format is concerned, you can go with the format of this course or the algebra and then go from one format. So x minus h quantity squared minus 4p times y minus k, or you can even go with this format. Remember, this opens up and down, up or down. So that means x has exponent 2. The vertex is clearly located at negative 3, comma 5. And the focus is located at negative 3, 319.64. And so let's write those. So those are the two pairs. We can clearly see that. And the focal distance is the difference between these two. This is the focal distance, everybody. That's the focal distance, is very little. So 5 minus 319 over 64, you multiply 5 by 64, subtract 319, you get 1 over 64. So this distance is very small, is 1 over 64. Now, x plus 3 squared equals minus 4 times p 1 over 64, y minus 5, according to this format. And when we multiply these two, we get negative 1 over 16. In other words, this doesn't change. So this is the format. X plus 3 quantity squared is negative 1 over 16, y minus 5. Or if we go with y equals a times x minus h quantity squared plus k, with the vertex at negative 3 comma 5 and a being negative 1 over 4p. So we have a times x plus 3 quantity squared plus 5. And of course, a is 1 over negative 4p because it opens down. It's important to know it opens down, so a is negative. And so negative 1 over negative 4 times the p is a focal distance. The distance, we go with the positive, okay? And so we get negative 16, and that's what we get. Now, another way of doing it, just so you can see, if you multiply both sides by negative 16 here, everybody, if I move this to the other side, that means I'm going to multiply by negative 16. I hope you see that. And if I move this one, that means I'm going to add 5. I hope you see that you can get to this easily. Okay, so it's very straightforward. All right. Given the function, express it in standard form. Now, this is the standard form in some text. I like to call it the vertex format. Okay, so you want to pay attention to the way the question is asking you. And find the x-intercept, the y-intercept, the vertex, the axis of symmetry, graph the function, and here's what you have. So number one, we're going to put these two together, everybody, which means we can factor the two out. And then this is b, and if you divide it by 2, you get 1. If you square it, you get 1 also. So you're going to add 1 inside. Now, it's important to know when you add 1 inside the parentheses, you're adding 2 times 1. So to undo it, you either add 2 to both sides, or you add 2 and subtract 2 to undo it. And so what we are looking at here is y equals 2 times x plus 1 quantity squared plus 4. And that's the vertex format. The vertex is located at -1, comma 4. So this opens up because A is 2 and you can find the intercepts. So A is 2 opens up. X-intercept, there is none. Well, you can calculate b squared minus 4ac from here. B squared minus 4ac, 4 squared minus 4 times 2 times x is -32. Remember, if b squared minus 4ac is negative, you don't have a real solution. It is real solution that corresponds to zeros or roots of a function. And so with that being the case, this has no x-intercept. And the y-intercept, you can see it from here, 0, 6. So we have the axis of symmetry, of course, x equals -1. So this is the vertex, everyone. This is the y-intercept 0, 6. Axis of symmetry x equals -1. And I hope you see that if I want to go with the axis of symmetry, and this is the vertex, this distance, if I go the same here, I should have another point here with coordinates such that the y coordinate is the same as this one. And again, because I want to make sure, let me just write this. So this was at 0, 6. And so the vertex located at -1, 4. If this distance is 1, so is distance 1, so this must be -2. That's how we arrive at it. And because it opens up, you just draw it like that, and you're done. All right, we want to identify the graph. These are conic sections. That's why we want to be able to, identify them. You can always put them in standard form, but I want to show you how you come up with the answer very fast without doing so. Okay, so first of all, basic circles, x squared plus y squared equals r squared. Ellipses, x squared over a squared plus y squared over b squared equals 1. Hyperbolas, x squared over a squared minus y squared over b squared equals 1. So those are reminding you of the graphs, the equation of the graphs that we have seen. Now, if you want to go with the conic sections, you really have to put them in this format. However, can you recognize this fast? The answer is this is a circle. How do you know that? Fast. Both x squared and y squared are there with equal coefficients on the same side of the equation. So we have x squared and y squared, and they both have identical coefficients on the same side, and that is important, same side of the equation. This one is an ellipse. Why is that? Again, we have x squared and y squared, and they both have a positive, the same sign, but they have different values. So both x squared and y squared are there with different coefficients and the same sign on the same side of the equation. So same side of the equation, we have x squared and y squared. But the value for the coefficients, although positive, they are different, as long as they have the same sign. Now, what happens here, this is a hyperbola. And one way to recognize it, just make sure x squared and y squared are on the same side. If they're on the same side, all they have to have the coefficients must have opposite signs. So both x squared and y squared are there with coefficients that have different signs on the same side of the equation. If they're on the same side, they have different signs. On both sides, identical signs. So in short, when you have x squared as well as y squared is one of the three. If x squared and y squared have identical coefficients on the same side, it's a circle. If they don't have the same coefficients, but they have the same sign on the same side, it's an ellipse. If they have different signs, one is positive, one is negative, doesn't matter which one. It's a hyperbola. Determine whether the graph opens up, down, left, or right. So you're looking at this situation first and foremost. All of them are parabolas. How do you know that? There is only one quadratic variable. You either have x squared or y squared, not both. So for example, please understand h of x means y, okay? Or f of x for that matter. So y has degree 1, x has degree 2. Y has degree 1, x has degree 2. X has degree 1, y has degree 2. Because you have one of them for sure, they must be parabolas, all of them. Now, parabolas like this open up and down. If A is positive up, negative down, like this, open sideways. Okay? A is positive to the right, negative to the left. So this one, because you have x squared, it opens up or down. Negative 2 means down. Same thing, you have x squared, opens up or down. But A is 1, positive, so it has to be up. Y has exponent 2, so it has to open sideways, right or left. Because A is 1. So let's write this in this manner. So in this case, A is negative 2. In this case, A is 1. In this case, A is 1. But this one opens to the right, so we don't want to mix them up a little bit.